Problem number 1, sections 7, 5, and 7, 7. Let us solve each equation and check each solution. So here we look at our denominators and we find the least common denominator, and the least common denominator here is 5. Therefore, we multiply all terms by the least common denominator to cancel our denominator. So multiplying every term by 5 cancels the 5. 5x divided by 5 is just x, minus 10 equals 45. Now we add 10 to both sides, and we solve for x. X is equal to 55. The next one, looking at our denominators, we have 6, 3, and 18. Our least common denominator is 18. Therefore, we multiply all terms by 18. Here we have 18x divided by 6, which is 3x, plus, or in other words, we can just, 18 divided by 6 is 3. 18 divided by 3 is 6. 6 times 4 is 24x. And here the 18's cancel, which we're left with just x. 24 plus 3 is 27x equals x. Combine like terms, which means we move the x to the other side. 26x is equal to 0. Divide by 26. X is equal to 0. The next problem here, looking at our denominators, our least common denominator is y. So we multiply all terms by that least common denominator. So we have 6 times y, which is 6y, plus here, your y's cancel, so is equal to 5, is equal to y times y is y squared, and that cancels minus 2. So let's combine like terms. Let's move the 5 over to the other side, and the 6y over to the other side as well. So we're left with 0 is equal to y squared minus 6y, negative 2 minus 5 is negative 7. Now we can factor. Again, we ask ourselves what two numbers multiplied equals negative 7 and added equals negative 6. And that is positive 1 and negative 7. And here we solve each factor. So y plus 1 is equal to 0, and y minus 7 is equal to 0. Solving for y, we have y is equal to negative 1, and y is equal to 7. And these are our solutions, negative 1 and 7. Problem number 2, solve each equation and check the proposed solution. Looking at our denominators here, our least common denominator is y minus 2. So we multiply all terms by y minus 2. So here for the first fraction, your y minus 2 cancels. So you're left with 2y minus, again, the y minus 2 cancels, 4 is equal to 4 times y minus 2. So let us distribute. 2y minus 4 is equal to 4y minus 8. Combining like terms, we add 8 to both sides, leaving us with 2y, negative 4 plus 8 is 4, equals 4y. Subtracting 2y from both sides, 4 is equal to 2y. Divide by 2, y is equal to 2. However, when you substitute 2 back into the equation, you are left with 2y over 2 minus 2, which is a denominator of 0. Therefore, you cannot have a denominator of 0, which means the equation has no solution. Otherwise, if you plug in the 2, it will be undefined. Therefore, you have no solution for this rational equation. Next problem, you have here an x squared minus 4, which is the same as x minus 2 times x plus 2. So our least common denominator is x plus 2 times x minus 2. Therefore, we multiply all fractions by that least common denominator. So we have 1 over x plus 2 plus 4 over x plus 2 times x minus 2 equals 1. So we multiply all terms by this least common denominator, x plus 2 times x minus 2. So when we multiply this first fraction by x plus 2 times x minus 2, your x plus 2 cancels, leaving you with the x minus 2. The second fraction, they both cancel, so you're left with just the 4, and is equal to 1 times x plus 2 times x minus 2. So now we can combine like terms. Again, remember this was x squared minus 4. So we can combine like terms. Negative 2 plus 4 is x plus 2 is equal to x squared minus 4. Let's subtract 2 from both sides and x from both sides, leaving it as 0. So 0 is equal to x squared minus x. Negative 2 minus 4 is negative 6. And here we factor like we did before, which two numbers multiplied equals negative 6 and added to negative 1, and that is negative 3 and positive 2. So here we can set each factor equal to 0 and we solve. So x minus 3 equals 0, x is equal to 3, x plus 2 is equal to 0, so x is equal to negative 2. And when you substitute these answers back into your original rational equation, you see that you have 3, so we can substitute 3 into the equation, and we're left with no denominators of 0. Therefore, 3 is a solution, but when you substitute negative 2 back into the equation, you have negative 2 plus 2, which is 0. Therefore, negative 2 cannot be a solution, which leaves us as x is equal to 3 is the solution to this equation. And this is the only solution because you cannot have a denominator of 0. Moving on to the next example of number 2. Again, looking at your denominators, your denominator is y plus 1, which means that is our least common denominator. So we multiply all fractions by y plus 1. So multiply the first fraction by y plus 1, the second one by y plus 1, and the 4 by y plus 1. So we have y plus 1 cancels. We're left with 5y minus 3y, just 3, because the y plus 1 cancels, is equal to 4 times y plus 1. So we distribute and combine like terms. So 5y minus 3 equals to 4y plus 4, subtracting 4y from both sides. Y minus 3 is equal to 4. Add 3 to both sides. Y is equal to 7. And when we plug in 7 back into the equation, we don't have any denominators of 0. Therefore, 7 is a solution. Number 3, simplify each complex fraction. Here we can solve this first complex fraction one of two ways. Let's solve it using the product rule, the division rule. So here we have 15 over 2x, and here we can flip the denominator and make it into a multiplication instead of a division. So we flip the denominator and we have 6x over 5. So now our division problem is now a multiplication problem, and we multiply numerator and we multiply denominators. 15 times 6x is 90x over 10x, and that answer is 9. Again, x over x cancels, and we're left with 90 divided by 10, which is 9. Now the second problem is a little different. Here we can't flip the denominator because here we have a binomial. We have two terms, therefore we can't flip it. But we can multiply all terms by our least common denominator. And our least common denominator is 3x. So let's multiply all terms by 3x in our numerator, and all terms by 3x in our denominator. So every term is multiplied by 3x. So here we have 3x times 5, which is 15. Here 3x over x, the x's cancel, so we're left with 3 times 3 is 9. Again, so we have 15x, 3x times 5 is 15x, 3 times 3 is 9. And the denominator we have 3x squared. And here again the x's cancel and also the 3's cancel, and we're just left with 2. And that is our final answer. Moving on to the next problem. We have our denominators as x squared and x. So that makes our least common denominator x squared. So we multiply all terms by our least common denominator, which is x squared. So multiply all terms by x squared. By doing that, the x squareds cancel, and we're left with 2 plus x squared over x is just x. Again, that's the quotient rule, x squared over x. 2 minus 1 is 1. So we're left with x to the 1 power. And here in the denominator, our x squareds cancel, so we're left with 4 minus x. And we can't simplify that answer, so we just leave it as 2 plus x over 4 minus x. Moving on to number 4. A to the negative 3, again remember our negative exponent rule. A to the negative 3 is 1 over a cubed. B to the negative 1 is 1 over b. A to the negative 2 is 1 over a squared. Looking at our denominators, our least common denominator is the higher degree, which is a cubed, and we also have a b. So we multiply all terms by our least common denominator, which is a cubed b, a cubed b. So here for the first fraction, our a cubes cancel, leaving us with a b times 1. The second fraction, our b's cancel, and that leaves us with the a cubed. In our denominators here, we have a cubed over a cubed over a. 3 minus 2 is 1. So we're left with the a and the b, and that is our final answer. B plus a cubed over ab. And our last problem is the same as the first. Again, a to the negative 1 is 1 over a minus 4 over 4 plus 1 over a. Our least common denominator is just the a. So let's multiply all terms by our least common denominator, which is a. So a times 1 over a is 1. A's cancel, in other words, you're left with 1 minus 4a. 4 times a is 4a, and here the a's cancel, and you're left with 1, and you can't simplify that, so you would leave it as 1 minus 4a over 4a plus 1. And that concludes Chapter 7, Sections 5 and 7.